Good afternoon, colleagues. I trust everyone is well. I'd like to greet everyone. My name is Brenda Digama. I'm the academic lead of research and the senior lecturer in clinical anatomy at the School of Laboratory Medicine and Medical Sciences. We're going to start with our webinar shortly. We're just going to give about 2 minutes for our other guests to join us, and then we will start officially at 15:05 on my watch. Thank you. Again, I'd like to welcome everyone. I believe we had a few more guests or colleagues or part of the UKZN community, and also the bigger academia space, and also anyone who is from the public that may have been joining us. You are please welcomed to our webinar titled Defining Pre-Diabetes and COVID-19, a Deadly Combination. So I'm sure probably maybe for others it may be a new first time that they're hearing of the term pre-diabetes, but it's a term that exists, which refers to a condition where you have a higher than normal blood sugar level, but it's not high enough to be considered to be type 2 diabetes. I'm not going to go further into that because I've got Mr. Aubrey Sosibo and Dr. Andile Kati to really take us through a presentation today. And then COVID-19, I believe we're all well informed about COVID-19, which is a disease caused by a new strain of coronavirus, which broke out in December 2019. So I'd like to welcome you all. I'll be facilitator for this webinar today. And how this webinar is going to run is that we're going to have our speakers take us through their presentations. And then what we will do is that we will not have any questions that are going to be taken after each presentation. We will take questions at the end. However, you are free to type in a question in the Q&A box, and at the end of the presentations, I will then go through each of the questions and we will have our presenters respond to each one. So the first speaker is Mr. Aubrey Sosibo, who will take us through further defining prediabetes and the pathophysiology of diabetes. Mr. Aubrey Mulelo Sosibo is a PhD candidate in human physiology at the School of Laboratory Medicine and Medical Sciences. He graduated with a Bachelor of Medical Sciences Physiology at UKZN in 2015. He then completed his Honours of Medical Sciences and Physiology and Master of Medical Sciences and Physiology as well at UKZN in 2016 and 2018 respectively. He is currently part of our PhD candidates and is completing it under the supervision of Dr. Kati and Dr. Ngubane in the endocrine research group. His PhD is investigating the prevalence and correlations of prediabetes within the eThekwini district and prediabetes' pathophysiology mechanisms. He currently serves as the Deputy Chair of the UKZN Physiology Postgraduate Society. He has been also involved in demonstrating practical sessions and presenting lectures for undergraduate MBCHB1 and medical science students in the university. Mr. Aubrey Sosibo, are you ready? I will hand over, Mr. Aubrey, I will hand over to you. You can do screen share and begin your presentation. Thank you.
Good afternoon to all. My name is Aubrey Sosibo. This will be a combined presentation between myself and Dr. Kati. The title of this presentation is screen. So the title of this presentation is The Prediabetes and COVID-19, a Deadly Combination. We are definitely living in unprecedented times as the coronavirus pandemic continues to rampage in all over the world. Indeed, great progress has been made scientifically in trying to understand this novel and invisible enemy. However, a lot remains unknown, and consequently, we raise this question. Could we by any chance be missing the silent killer in prediabetes? For a long time, the notion about diabetes has been that a person can either be non-diabetic or diabetic. Well, there is a state between these two conditions, and that is pre-diabetes. Pre-diabetes can be defined as an intermediate state of hyperglycemia, preceded by insulin resistance. In this condition, the blood glucose levels is higher than normal, but not high enough to diagnose with type 2 diabetes. The prediabetes condition is considered as asymptomatic. Consequently, one can have prediabetes for years but present no clear symptoms. So it often goes undetected until serious health problems such as type 2 diabetes show up. The asymptomatic state is actually credited to the body's compensatory mechanisms that prevent further disturbances in blood glucose levels. For example, when insulin-dependent cells in your body fail to respond to insulin normally, your pancreas will begin to secrete more insulin to try to get the cells to respond to insulin better. Also, there are several risk factors associated with prediabetes. For example, diet. The kind of food you consume can make you either more or less susceptible to prediabetes. Also, physical inactivity and having a first-degree relative with diabetes. Not forgetting age. For the more we progress in age, then the more susceptible we become to getting prediabetes. So, for the diagnosis of prediabetes, the WHO and ADA diagnostic criteria can be used. They determine through analysis of specific parameters such as impaired glucose tolerance. In impaired glucose tolerance, a patient is deemed to have prediabetes if they have 2-hour glucose levels of 7.8 to 11 millimoles of 75 grams OGTT. And in the impaired fasting glucose state, in this case, a fasting patient is regarded as having prediabetes when they have glucose levels of 5.6 to 6.9 millimoles. Lastly, the glycated hemoglobin. The glycated hemoglobin test tells you your average levels of blood sugar over the past 2 to 3 months. And the value between 5.7% to 6.6% is defined as prediabetes. Therefore, now that we know how prediabetes can be diagnosed, what is the current prevalence of prediabetes? Globally, the prevalence of prediabetes was at 373.9 million people in 2019, with the majority, that is 72% of them, being people living in low and middle income countries, such as in South Africa. And in South Africa, it is estimated that 5 million people have pre-diabetes. And however, we should remember that most people with pre-diabetes remain asymptomatic. Therefore, it is very likely that more people will remain undiagnosed. And the increasing pre-diabetes prevalence is attributed to sedentary lifestyles and a high caloric diet. Also, future projections estimate that over 453 million and 548 million people will have prediabetes by the year 2030 and 2045 globally. Yet, to stop this growing prevalence, we need to first understand the mechanics that lead to prediabetes development. Now, there are 4 documented defects underlying the development of prediabetes. 1, skeletal muscle insulin resistance, whereby insulin receptors on the muscle cells fail to recognize insulin. 2, impaired insulin secretion by the pancreatic beta cell. 3, dysregulated hepatic glucose production. And 4, increased lipolysis. All these defects can independently or collectively cause prediabetes. And interestingly, individuals with impaired glucose tolerance or impaired fasting glucose display different pathophysiological mechanisms. How? In impaired glucose tolerance, muscular insulin resistance is seen, whilst in impaired fasting glucose, hepatic insulin resistance is observed. Now, let us zoom in into both these conditions. In normal conditions, insulin stimulates glucose uptake by binding to the insulin receptor. And this triggers a cascade of events that cause GLUT4 vesicles to be translocated to the membrane where glucose is allowed to enter the cells. But patients with impaired glucose tolerance appear to have a less functioning insulin signaling pathway, possibly through blockage on the insulin receptor. And as a result, blood glucose levels will rise. And if this is left unattended, it would increase the chances of developing type 2 diabetes. Now, in the hepatic or the liver, under normal conditions, insulin will stimulate glycogenesis and lipogenesis. However, in the impaired fasting glucose state, there will be hepatic insulin resistance that will inhibit glycogenesis and lipogenesis in the liver. And as a result, this will lead to dysregulated hepatic glucose production, and blood glucose levels will begin to rise, which also increases the chances of inducing type 2 diabetes. So, in summary, prediabetes is an intermediate state of hyperglycemia, which displays no clear symptoms for it to be easily detected. However, biochemically, we know that moderate alterations in the hepatic and muscular insulin sensitivity exist in prediabetes. And we can liken prediabetes to this image here, or where things look merry on the outside, but in the inside, it is a total opposite. Now, let me allow Dr. Kati to take you to the next section. Dr. Kati.
Thanks, Aubrey. Good afternoon, everybody. And thank you for everybody for making time to come and listen to us. We really appreciate it. So my name is Andile Kati, and I'll be taking you guys, and I'll be talking to you guys about prediabetes and its potential links with COVID-19. Now, I think I should put a disclaimer right from the get-go that I am a physiologist and not a virologist. So I might get some of the details not 100% correct. So I've tried to put more emphasis on the physiological aspects, and I also know that we don't have, it's not all scientists that are within the audience. So I want to try and make it so that everybody sort of understands. So in this segment, I will try to explain the effects of prediabetes on both the infection and replication, as well as the effects of prediabetes on the inflammatory response. So I'll try and take you guys through all of those. So let's first take a look at the infection and replication part. So under normal circumstances, if you guys have a look at that first diagram there at the top, the level of glucose indicated in blue is within the homeostatic range, which means it's in the normal, you have normal levels of glucose. The virus that causes COVID-19, indicated by red, the SARS-CoV-2 virus, needs a target. In order for it to get into the cell, it needs a target to latch onto so that it can invade our cells. So that's usually a protein called on the surfaces of our cells called ACE2, indicated by our green. So now, depending on the expression of ACE2, the expression of ACE2 is dependent on the amount of glucose that is there within the blood. So in simple terms, the higher the level of glucose within the system, the more you have ACE2 expression. So like I said, the higher the level of glucose, the higher the ACE2 expression. So in the non-diabetic states with very normal levels of glucose, with controlled levels of glucose, there's minimal expression of ACE2 where the virus will be able to attach. So this means that there will be slower entry or minimal entry of the virus into the cell, and also leading to lower rates of viral replication because there's not a lot of virus that is entering the cell at all in one go. However, let's look at diabetes. Diabetes, if not controlled well, can result in very high levels of glucose. As you can see that the blue dots, there's more blue dots now. So this will lead to higher levels of ACE2 protein on the surfaces of our cells, because ACE2 is dependent on the level of glucose. Now, once there's more ACE2 expression on the surfaces of our cells, what this will mean is that it will allow for increased latching of the virus onto the cells. And when this happens, it will mean increased entry of the virus into our cells. Now, because of this, there might be higher rates of replication, because there's more entry of the virus within the cell in uncontrolled diabetes. So now let's look at our phase, the pre-diabetic phase. Now, in the pre-diabetic state, like Aubrey said earlier on, the blood glucose concentrations are lower than in the diabetic state, but higher than in the normal non-diabetic state. So again, this is why we have slightly less blue dots in the diagram. What this will mean then is that there will be also slightly less ACE2 expression on the surfaces of the cell when you compare it with the diabetic, but they'll definitely be higher than those observed in the non-diabetic diagram. Again, what this will mean is that there's increased levels of ACE2 expression, more attachment of the virus onto the ACE2, therefore leading to higher levels of entry of the virus into the cell. So again, you've got more entry of the virus into the cell, which means when you compare it to the non-diabetic, so essentially what happens in the pre-diabetic state is that the virus can more easily access our cells when you compare it with the non-diabetic phase. So although the blood glucose levels in the pre-diabetic phase are not very high, they are high enough to cause increased expression of ACE2, which will allow increased viral attachments and viral entry into the cells, as well as higher rates of replication. So I thought that would be the first part that I would discuss with you, just so that you get a brief understanding. So then the second part that I would like to talk to you guys is how COVID is linked to inflammation. Now, a common feature for many patients that get severe COVID symptoms is serious lung damage that is caused by an overly vigorous immune response. So when the body is trying to help out, it ends up creating more of a problem for itself. So this is characterized by the creation of lots of inflammatory cytokines that I'm going to talk about, called cytokines. Now, this is what many people refer to as the cytokine storm. So under normal circumstances, what happens is the production of these inflammatory cytokines can be good because they're really powerful tools in the immune response. So for example, they can stop viruses from reproducing. However, some cytokine actions, or some of the actions from these cytokines, such as helping bring in other immune cells to fight an infection, or enhancing the ability of those recruited cells to get across, can be overexpressed, and they can cause real damage if they are left uncontrolled. Now, if it is uncontrolled, in the case of COVID, it can result in hyperinflammation in various tissues, and these tissues can be the lungs. And this is why we saw this causes breathing difficulties in patients that have COVID-19, and this can lead to potentially acute respiratory distress syndrome. So this is now why we understand why people with COVID get those breathing difficulty. It is because of the inflammation that is there within the lungs. So now I want to talk to you guys about diabetes and COVID. So like I said earlier on, a little inflammation is good, as it is well below the danger zone. So I've got a nice diagram again here, just so that everybody understands. So with the red line, I'm indicating a danger zone, where if the amount of inflammation in your tissues or in your system gets to that level, you then start experiencing hectic symptoms because of that cytokine storm that we spoke about. Now, like I said, a little inflammation can be good because it is well below the danger zone indicated by the green. In diabetes, though, there are higher amounts of inflammation or pre-existing inflammation, which are, as you can see with the orange, a lot closer to the danger zone. So the non-diabetic person has significantly less inflammation, pre-existing inflammation, when you compare them to the diabetic individual. Now, let's say now we've got COVID-19, which also causes inflammation. Now, when a non-diabetic individual contracts COVID-19, again, this will cause inflammation and it will add onto the pre-existing inflammation that is there in the non-diabetic state. But in most cases, it will still not reach the danger zone there in red. This is why some people who are non-diabetic don't experience those severe COVID symptoms, because the amount of inflammation that is there does not reach the danger zone. Now, I want to take you guys through what happens in the diabetic patients. When a diabetic patient contracts COVID-19, it adds onto the already existing high levels of inflammation that are there and gets the patients well within the red zone. So this is part of the reason why diabetes patients are considered higher risk for developing severe COVID symptoms. It all has to do with this inflammation. And this is why they experience very hectic breathing difficulties and other inflammation in other tissues as well. So recent findings from our lab. So we've got a couple of students that have been doing nice work. So we've got Palisa, who showed that pre-diabetes causes a compromised immune response. This is critical in this particular time, as we need to be able to manage our stress levels very well during this pandemic. Another study by Unom Samzimela also showed that pre-diabetes compromises the immune system or the immune response. And again, this is critical, as I'm sure everyone needs the immune system working at its best during this time. And then lastly, we had another study by Umlindele Gamete that showed that pre-diabetes induces chronic subclinical inflammation. Now, what this means in the context of this talk is that the levels of inflammation in pre-diabetes are lower than what was observed in the diabetic state. But as you can see, they are higher than what is there naturally in the non-diabetic state. So if this pre-diabetic patient in yellow somehow contracts COVID-19, what this will mean is that because COVID-19 also adds on some inflammation, is that this will exacerbate the already existing inflammation and bring the patients to the danger zone. So essentially, this could explain why severe COVID symptoms can be seen in some instances, as well as some mortalities. This is why we've seen severe COVID as well as mortalities in people that are generally considered to be non-diabetic and not at risk. So this pre-diabetic phase, indicated in yellow, combined with COVID-19, could be, so the pre-diabetic phase seems to possibly be, as Aubrey would put it, the silent killer. I hope everybody is still keeping up with this. So Aubrey mentioned earlier on that some beta cells. Now, recently, some studies that are there in literature showed that there have been cases where COVID-19 leads to the destruction of the insulin secreting cells or the beta cells in the pancreas. Now, this means that if a pre-diabetic person contracts COVID-19, might end up with increased loss of these insulin secreting cells, leading to less insulin being secreted and essentially to the development of full-on or overt diabetes. And this again could explain why we're seeing reports that there are some people who were considered non-diabetic before the infection, but later developed full-on diabetes after the infection. Secondly, let's talk about some fatigue. So some pre-diabetic patients have reported occasional mild fatigue, which is attributed to the onset of moderate insulin resistance. So in pre-diabetes, some patients, even though it's not a recognized, some patients will say that they often experience on and off fatigue, so it's occasional. Now, on the other hand, some patients, some COVID-19 patients have also reported fatigue during both the infection and the recovery periods. Now, if you combine, again, these two together, this could mean that there is a possibility that should a pre-diabetic person contract COVID-19, this could lead to extreme fatigue or exacerbated fatigue. And this could perhaps explain the extreme fatigue that is reported by some COVID-19 survivors who long after infection, but who were considered non-diabetic before. So what this suggests is that in the pre-diabetic patients might feel the after effects of COVID-19 much longer than the non-diabetic people. So in summary, what I wanted to try and get across today is that pre-diabetes creates this toxic environment that could worsen viral infections such as COVID-19. So prediabetes was a hidden and untreated condition that causes inflammation. And with our paper that we published, what we want to suggest is that prediabetes and COVID-19 could be the deadly combination that we were missing, but now that we know, it could deserve our attention. So I thank you for your attention. I'll bring it back to Aubrey, who will take us and give us a bit of sunshine after all those disturbing news. Thanks.
Thanks again, Dr. Kadi. So after what Dr. Kadi has spoken, some of us may be thinking, is there any hope now? I came to tell you, yes, there is hope. Why? Several studies have shown that prediabetes is reversible. These studies have highlighted the best possible interventions that can be taken to reverse prediabetes. And I'm now going to share a few of them. The first intervention is change of diet by reducing the intake of carbohydrates and moderate intake of unsaturated fats and protein. Another intervention that can be taken is increasing physical activity in order to increase the caloric output so that less weight can be gained. This can be achieved by daily or regular walks or light joggings. Furthermore, there are certain foods that can help with fighting inflammation. And I've made a list of some of them here, which one can increase or accommodate into their diet in order to fight off inflammation. And also, finally, these are also our recommendations that we suggest. Firstly, we recommend that prediabetes be treated as a comorbidity. And then also, we recommend that there be follow-up studies on patients who show glucose levels at admission, so that we will know whether there are any new cases of the onset of diabetes, as Dr. Kadi spoken about earlier. Again, we recommend that there be an increased awareness of prediabetes. This will help fight any future incidents of type 2 diabetes, and also help many people to reverse this condition. As I've mentioned, that it is reversible. Also, let there be an increased screening and testing for this condition. Furthermore, more studies on pharmacological diabetes and pre-diabetes treatment in relation to COVID-19 should be undertaken. Lastly, this is very pivotal because it will allow healthcare workers to implement timeous dietary lifestyles and pharmacological interventions if we take the recommendation I've mentioned earlier. Then, lastly, because this presentation will be made available online after the session, here is a risk test that one can take to check whether they may have pre-diabetes. It's quite straightforward and it shouldn't take you more than 2 minutes. However, only your doctor can tell you for sure if you have pre-diabetes or type 2 diabetes. So we do recommend that after taking this test, that you go see your doctor to get tested. These are our references, and thank you.
Thank you so much, Mr. Aubrey Sosibo and Dr. Kati. I didn't get a chance to tell the audience about Dr. Kati, so I'll do that now. You've already heard from him, and he was looking at the potential links between pre-diabetes and COVID-19. Thank you to both of you for quite an informative presentation, actually. So Dr. Kati is a senior lecturer at physiology in the School of Laboratory Medicine and Medical Sciences, and he joined the university in 2015 and was appointed as a lecturer in the discipline of human physiology, where he is based at the moment. He is also the academic leader of the Human Body Form and Function Research Team in the School of Laboratory Medicine and Medical Sciences. Graduated with a BMed Sci degree at UKZN in 2010 and completed his honors in medical sciences cum laude in 2011. In 2013, he did a master's and he upgraded it to a PhD study and graduated for it in 2015. He is currently a co-leader of the endocrinology group, which is they are part of the group, both of them, and Aubrey is part of the group, and Dr. Kati is a co-leader in the endocrinology group, which is hosting this webinar today. And they focus on studying the origins of various endocrine disorders with a primary focus on prediabetes. He is actively involved in undergraduate teaching as well as the supervision of honors, masters, and PhD students. We were supposed to have another speaker, the dietitian, join us, but they apologized and couldn't join us today because of not being well. And we apologize for Prof. Susanna Kasia and on her behalf. Thank you for the informative session. I believe we had great insights, very interesting use of diagrams as well for your presentations to make the point come true, especially with regards to non-diabetic, diabetic, and then pre-diabetic, and how the attachment ACE2, I really enjoyed that because it gave a good picture on how it works, and also the inflammation and what happens between a diabetic and a non-diabetic, and the pre-diabetic, and how the inflammation works. So now we are going to move on to the questions that we have in our Q&A box. Dr. Kati and Mr. Aubrey, you are ready? All right. So the first question is, and I believe Mr. Aubrey answered this towards the end. The question is pre-diabetes reversible?
Yeah, as I've mentioned already, yeah, it is reversible. And this just adds more emphasis on that. If it is reversible, then more action should be taken in identifying people early, whether they have pre-diabetes or not, so that we can prevent further incidence of type 2 diabetes, which is pivotal risk factors for people with pre-diabetes. So if you follow the recommendations that we took, we believe that you'll be good space. Thanks.
Thank you, Mr. Aubrey. The next question is, why would a diabetic have higher levels of inflammation within the lungs? Who's taking that one? Dr. Kati, you spoke a lot about inflammation. I don't know if you want to take that question.
Okay, thank you. So there's another study. The only reason why I didn't include some of the work is that it is still unpublished, but it is under review at the moment. So what we saw, she took all these tissues from samples and increased amounts of inflammation even within the lungs, because we wanted to see this inflammation within various tissues. So we know that there's quite a high emphasis. So initially, when we started this, we didn't really have all our attention on the lungs, but we were looking at tissues like the kidneys, the liver. But what we saw inflammation within the lungs as well. And I think it all might have to do with the inflammatory response, and the glucose levels. So we still trying to find out the exact molecular mechanisms, because it is an ongoing study. So we really can't comment too much on it at the moment. But there are preliminary results that do show that during the pre-diabetic and the diabetic phase, there are high levels of inflammation within the lungs.
Thank you, Dr. Kati. The next question is, the SARS-CoV-2 S protein binds to the ACE2 receptor. Is this receptor in any way associated with diabetes and or pre-diabetes?
Okay, thanks. I think I'm going to cover this one again. So that like I said, I think with the ACE2 receptor, the ACE2 receptor, that is actually a good question, because what happens with the ACE2 receptor, its expression is sort of directly controlled by the glucose levels that are there within the system. So like I said, that when you have very low levels of glucose, consistently low levels of glucose, there's also going to be low levels of that ACE2. And the higher your glucose levels go, the more expression that there is going to be of the ACE2. So in diabetic people, or people with overt diabetes, there's going to be very high levels of expression of the ACE2 receptor. But in the pre-diabetic state, there's moderate expression of the ACE2 receptor. And like I showed in the diagram, the ACE2 receptor plays a very critical role in the entry of the virus into the cell. So by directly managing your glucose levels and making sure that they're quite lower, you're also indirectly lowering the expression of SARS-2 or of ACE2. And then what will happen is that you're less susceptible, or not less susceptible, but there could be less entry of the virus into the cell.
Thank you, Dr. Kati. Then there was a question of being able to receive the presentation via email. I think Lihle, you'll assist us there. Maybe you can drop the answer to that on the Q&A box, if it's possible. I don't know if the speakers are willing to share their presentation via emails. Okay, let's move on to the next question. The guest says, thank you for the interesting presentation. Based on this, could it be possible that pre-diabetic patients go to develop type 2 diabetes after recovery from COVID-19? Is it clear?
Yeah, it's clear. So about network there. So what studies have shown that people with pre-diabetes are at risk to develop orbit diabetes, and this is understandable because in pre-diabetes there's moderate hyperglycemia. So if this condition is left unattended, what will happen is that subsequently your compensatory mechanism that I spoke of will give up, and next day you will begin to progress to type 2 diabetes. So definitely, if left unattended, chances are very high that you will develop type 2 diabetes. And in fact, some studies even say that all type 2 diabetes cases are preceded by pre-diabetes. So yeah, I'll leave it there.
And then the pre-diabetes wasn't detected early, and hence it then develops into type 2. Interesting. Thank you, Mr. Aubrey. Right, the next question is pre-diabetes more common in certain racial groups among the lower income group? Please explain.
I'll take the scale. Yeah, definitely. So when we look at pre-diabetes, it's very similar to type 2 diabetes. And a lot of evidence have shown that certain races are more susceptible to this condition. So likewise can be expected with pre-diabetes. So, so one of the studies I've read have shown that in South Africa, they've been shown that Indians are more susceptible to pre-diabetes, followed by the colored or mixed race population, and also the African Black people. They have been shown to be more susceptible. So what comes into here is the genetics, the epigenetics, basically. So we know that sometimes genetics play a role in actual being susceptible to pre-diabetes, but this is ongoing, and more studies on pre-diabetes need to be done.
Thank you, Aubrey, because as you were explaining, I was going to ask then, are you guys looking into the epigenetics part? And you can do a nice collaboration within the school with that. So that's great. The next question is, I would like to know what happens when someone checks his or her glucose level is high with no digits?
No. So I think I can understand. I think I understand what the question is asking. So usually, if it says high, it depends on the equipment that you're using. So I know that with the glucometers that we use over here, so all glucometers have a lower and an upper limit. So if your blood glucose levels are lower than 1.1, it will just say low, because the blood glucose reading is usually lower than 1.1. But it also has an upper limit, but these vary with the different types of glucometers that you use. But the one that we've got over here has an upper limit of 33.3 millimoles per liter. So so usually when it says high, then we know that the glucose levels are above the upper limits of 33.3. So yeah, that's generally what it means. And again, we're not here to, I think we need to emphasize that we are from the School of Laboratory Medicine and Medical Sciences. So we're more in the lab, and we don't have the right to tell you what to do. But as a personal suggestion, if your blood glucose levels are above that range, I would genuinely suggest that, personally, not in my academic standing, but as a personal thing, that you go and consult your doctor and get proper advice.
Thank you, Dr. Kati. We move on to the next one. I see we also have some questions in the chat box, so I want to carry on so that we can get to those as well. So the question is, if you are diagnosed as pre-diabetic, do you have to take medications as opposed to dietary actions? I remember Aubrey stated that it's the diet and you can do physical activities. So the person is asking, do you have to take medications opposed to dietary actions?
Okay. For now, there is no specific medication that are actually prescribed for pre-diabetes. And that's why in the paper that we published, we recommended that there be studies that now introduce the treatments such as metformin for pre-diabetics, so that we can see whether it will help them in getting. But the common suggestion for people with pre-diabetes is that they should undertake lifestyle modifications to reverse this condition, because more studies are needed for any treatment to be actually recommended. Because the fear is, if you give someone a drug, perhaps like metformin, to take, what if their blood glucose shoot down dramatically? So hypoglycemia can result. So we need to be cautious about that. So I cannot recommend a medication at lifestyle. Thank you.
Thank you, Aubrey. That was clear. The next question, it says, thanks to Aubrey and Dr. Kati, which is well-deserved indeed. I would like to find out perhaps if pre-diabetes may also result in vitamin D deficiency. That's part one of the question. And secondly, regarding hyperglycemia on admission, could it be attributable to stress due to COVID-19, or is it pre-diabetes? Is it due to, I think he was trying to say that, is it due to diabetes? Who's taking it? Dr. Kati, you are not unmuted.
Okay, thank you. Yes, thanks. I'm going to take this. So the first part of the question is the vitamin D deficiency. I think I just want to highlight that with the pre-diabetes, there's a lot of work. It's a relatively new area. So we've got a lot of students that are doing work. And at the moment, we do not have somebody who is looking at pre-diabetes and vitamin D. So it's just that I can't see who asked the question, but it's giving us some nice ideas. And if the person could come through, we could register and we could do some nice work on that specific area. I know that vitamin D has been the subject of a lot of talks in the media regarding COVID-19. But personally, what we have done is that we haven't, because, actually, we've got Karishma Naidu, who's doing work on calcium homeostasis, and that looks at vitamin D, but she was an honors student last year and she's continuing with the work at master's level this year. So if we have such an opportunity again next year, I'm sure she'll have more data to share, and then we'll be able to shed more light on that. And then with hyperglycemia upon admission, the question was, is it based on the stress or is it based on the pre-diabetes? Honestly, it could be either. Like I said in the presentation, there's a study done by Palisa where she showed that there's dysregulation in the HPA axis, which basically means that people with pre-diabetes don't handle stress in the same way that people without pre-diabetes handle it. So there's dysregulation literally in how people handle stress, and what that does is that it predisposes them to conditions like anxiety. So, but what those very high levels of stress do is that they also increase your blood glucose levels indirectly, because the hormone cortisol is secreted. And when there's very high levels of cortisol, there's higher levels of glucose in the system. So stress in itself it can be a contributor to very high glucose levels. This is why we need to be able to manage both the stress and the the stress levels during this pre-diabetic, during this COVID-19 pandemic. So it could be the stress and it could be the pre-diabetes, as we've mentioned. But like we said, the best thing to do is go to your doctor and ask them for advice, get the proper test done, get your stress hormone levels checked out, so that he will have, or the doctor will have, a more rounded view of your personal condition, because we can't make general statements. Thanks.
Very important, yes. Definitely have a complete view of everything before, yeah. I agree, Dr. Kati. So I'd like to just try and speed up the questions now. We've got quite a number already in the Q&A session, in the Q&A box, and we have some on the chat. So the next one, I'll just give you two. Maybe one can take one. One of you can take one, I'm not sure. The question is, are pre-diabetic or diabetic children also at a high risk as adult patients for COVID infection? Are pre-diabetic or diabetic children also at high risk as adult patients for COVID infection? I see the discussions, Dr. Kati.
Okay, so we're gonna take this one. I'm gonna take this one, but again, I don't think that what we do know for a fact is that the children are less susceptible to COVID-19 or to severe COVID symptoms. So they can be carriers, but it won't necessarily lead to severe symptoms as is the case with adults. I have never personally seen any studies that look at, especially juvenile onset diabetes, type 1 diabetes, and how that affects younger children. We know what the effects that type 1 diabetes have on adults, but I haven't personally seen a study where there's diabetes and COVID in young children, because those are two there's two variables there. So I don't want to lie or give off incorrect information. So right now I don't know, and maybe that's something that we could read up on in the future.
Thank you, Dr. Kati. The next question is the use of corticosteroids recommended in diabetic and pre-diabetic COVID patients?
Okay, so when we were preparing this presentation and when we were writing the paper, we thought about including the use of corticosteroids, such as your dexamethasones, but so we can't recommend what can be taken and what cannot be taken. I think last week, this College of Health Sciences at UKZN hosted an ivermectin debate, and I know that there's a lot of studies on ivermectin, and there's this new anti-inflammatory drug for arthritis, because all of these drugs, what they do is that they decrease the amount of inflammation. That's their mode of action. They work to decrease the amount of inflammation, which is essentially what you want. Well, if you have a lot of inflammation due to the COVID and the diabetes. But on the flip side, what they also do is that they also increase your glucose levels in the system. So that's why there's a debate at the moment. And us personally as lab scientists, we can't make a statement on whether people should use them or don't use them. There is always going to be advantages and disadvantages to any drugs. And most of the time we need to look at whether the advantages hectically outweigh the disadvantages. So that's where we are with that at the moment.
Thank you, Dr. Kati. The next one is, it says, is this inflammatory upregulation a good or bad thing? If either good or bad, what can it mean for the pre-diabetic body? There are still a discussion who's taking it.
Okay, no. So with the inflammation, like I said, some inflammation is good. So basically, it's there to help and recruit more immune cells to try and fight off the infection. So under normal circumstances, it's good, but when there's too much inflammation, that's the problem here. That's why we refer to it as a cytokine storm. When there's too much inflammation, that's when it becomes dangerous. So under normal circumstances, if you have a bit of inflammation, what's going to happen is that it's going to come through. It's going to help recruiting immune cells. There's a lot of functions for the cytokines for them during this inflammatory response, which are beneficial to the individual. But too much of a good thing in some instances, like people saying, can be bad. So when there's too much of this inflammatory response, then what happens is that it becomes bad for your body. So this is why Aubrey came up with those nice suggestions for those anti-inflammatory interventions that can be employed later on.
Okay, thank you, Dr. Kati. The next question is, which inflammatory cytokines are shown to be elevated specifically, or they wrote elevated?
So basically, pro-inflammatory cytokines are upregulated in this case. So we looking at inflammatory cytokines such as interleukin-6, your TNF-alpha, and as such, which are shown to be high in this case.
Thank you, Mr. Aubrey.
Thanks.
Then you have a comment that says, thank you so much to Aubrey and Dr. Andile. The presentation was very informative. Then you have someone who's wondering if a low-carb diet or an intermittent starvation, which they call intermittent fasting, during COVID-19 treatment would yield significant results. What is the take on this by the presenters?
Yeah, sure. Well, for now, there's no concrete evidence that we can say, or this should be done. But this is a likely study that can be undertaken. So whoever raised this question, I think it would be one of those interventions that we can introduce to see whether it helps. But in a way, the low carb comes with the intervention I mentioned earlier with your change of diet. So that's intervention that we can already recommend. And the intermittent fasting, I know that the intermittent fasting is like the new thing. It's quite popular online, but we cannot recommend that as a recommendation because for now there's no study that has been investigated in people who are pre-diabetic and infected with COVID-19. So thank you for that question.
Thank you, Mr. Aubrey. We're getting to the last set. So it's a second question from a previous attendee who asked this. They're asking how far of a role would genetic variation play? That's part one. What role would environmental factors play? Are there any studies thus far showing gene X epigenetic interaction in pre-diabetics? And then if so, what have they found? And then the last question it's a packed question. What is your view going forward to better understand these relationships?
Thank you. So I think I know who asked the question because so essentially, like I think Aubrey touched on this earlier. Some of the things that part of Aubrey's study is looking at the differences in race first, and the incidence of prediabetes and how they respond. So we might be looking at the genetic component. So this is a study that only began 2019, and we haven't gotten to that part of the work as yet. But it is studies that we will be looking at. So when it comes to data, where we've looked at various variations, we haven't gotten to that part as yet. And perhaps we know that the person who asked the question, because we know him, that's one of his areas of speciality. So we welcome collaborations. We're always looking to work with people who want to get involved with the work. So if there's anybody out there as well who wants to look at the genetic components, who's very, very well versed, you're more than welcome to come along and help us.
Okay, definitely. I love how the collaborations are springing up through this discussion, and we encourage those. Right, last two. Is diabetes more prone to lifestyle or genetics? I think this is a quick answer one. Can I just include the very last two as well? Then you can tackle those at the end. Then we can move to the chat. I think there's just two questions there. The last one is, does ACE2 expression differ by race? If so, does this explain how other studies show that some races are less susceptible to getting certain COVID-19 strains than in others? Thank you.
Okay, I'm going to start with the first question. Thank you for that. So, is diabetic more prone to lifestyle or genetics? We haven't looked at the genetic part, like I've been saying. So, but we've heavily looked at the lifestyle. We've looked at what happens when people eat unhealthily, and we've looked at what happens when people, or unhealthy foods, and we've also looked at what happens when people don't exercise. And those lifestyle things make it very, very easy for the people to develop pre-diabetes, which later develops to type 2 diabetes. The other part is that we've seen, I think there's a study by one of our PhD students, Mr. Lulegu, who looked at how exercise directly can reverse pre-diabetes. We've also got several studies that showed that when you change your diet to a certain condition where you decrease the amount of carbohydrates, again, it reverses you back to normal. So we think that lifestyle does play a very, very big role in the development or susceptibility to developing conditions like pre-diabetes and diabetes, but we have not looked at the genetic component. So, and like I said, we do welcome the collaborations, because those are things that we would like to look at in the future, so that more information is out there. Because what we do want is, we want COVID-19, we want pre-diabetes to be a recognized field of research and to be recognized as a comorbidity, and so that there's more awareness and that more people know about it, so that they prevent themselves from going on into the type 2 diabetes phase. So that's that's the general aim of our research. And all these ideas that are popping up now, we're noting them down so that we carry on and make the research more insightful. Thanks.
Definitely, prevention is better than cure. The ACE2 expression, does it differ by race? Have you covered that one, Doc?
I don't think
spoke about the genetic
any studies. Yeah.
Okay.
Yeah.
All right. Thank you. Okay. So on the chat box, it says COVID-19 may be diabetic for people who had no such before. Can you end up being diabetic after COVID-19? I think that's what they're trying to say, when you had not had it before.
Yeah. Well, studies have indicated that there appears to be new onset of type 2 diabetes in patients admitted with COVID-19. So the speculation comes, Dr. Kadio spoke about it, that the possible damage that occur in the pancreatic beta cells because of this inflammation that takes place during COVID-19. So yes, you can eventually get pre-diabetes or type 2 diabetes after the infection of COVID-19. And this is also, interestingly, I also saw another study about the Spanish virus, but the first coronavirus pandemic. And studies in that time, they've shown that patients who had this coronavirus, after some time, they were diabetic. So it's not really new. So it's something that has been observed before, but now just that it's being confirmed again with COVID-19. So yeah.
Thank you, Mr. Aubrey. And then the question is, I think we covered it in part of the discussion. Should pre-diabetic patients be put on insulin or oral treatment? I think this was covered before, but you can repeat it, Mr. Aubrey.
Yeah. Oh, okay. Yeah, I think, as I mentioned earlier before, at the moment, there's no study that has been taken to evaluate the effectiveness of treatments such as insulin or whatever metformin whatsoever. So for now, this is something that needs to be conducted or investigated to see whether it's effective or not. Because This is a different case. This is pre-diabetes combined with COVID-19. So in this state, it should be more beneficial if we introduce such treatment. Unlike when it's a person who's normal diabetic, they normally don't recommend taking treatments. But I found that in some countries, such as in America, they've said that patients with progressed or pre-diabetes, they've suggested that they take moderate metformin as a treatment. But yeah.
Thank you, Aubrey. Then there's one that's asking about age or race prevalence, and I believe it's in the context of pre-diabetes. I know you are working on this, Mr. Aubrey. Are you? I don't know who's taking it, Dr. Katya, Mr. Aubrey. Unmute, please.
Just repeat the question for him.
What's the age or race prevalence? And it doesn't say which context diabetes. It's on the chat box. Age or race.
Okay, take it.
Okay.
Can't see the question.
So, but essentially, the age and the race prevalence. Aubrey said that at the moment when they did the study, and this was quite a while back, they found that there were 5 million people who were pre-diabetic in the country, but they didn't categorize them by race. But because this was just a big study that I think it was more of just trying to get an idea of what's happening. So part of Aubrey's PhD is looking specifically in the eThekwini region. So what we're doing is we're collecting these blood samples from the area, from the eThekwini region, and we're trying to get this. So we're looking at age, we're looking at race, we're looking at all these factors so that when we do work, we work with specific numbers. So that's part of his PhD, and I think that we're making some nice progress. So we haven't started with any data analysis, but like I said, if we have this opportunity again next year, Aubrey will be able to tell you all about it.
Of course. That's why I was wondering if he's willing to share anything now. I look forward to it. All right. Let's just try and finish off. Okay. And then one person comments and says, great presentation, team. And they say, thank you for your responses. And then the next question is, how can we institutionalize interventions that strengthen screening for pre-diabetes in resource-limited settings? That's a very important question. Relates to healthcare. They're taking you out of the lab.
Definitely, we're going clinical or public health, rather. So, but let me try to answer this. How can we institutionalize interventions? So, if you noticed, even the last slide that I presented, I showed up this risk score, this pre-diabetes risk score. This is highly utilized in countries like in America. And I thought such tests should be also incorporated into our institutions because it increases awareness. And also it's quick, 2 minutes, you don't need any injections, you don't need to go to the doctor. So with that, people can take those tests and see whether they are at risk or not. But as I stressed earlier on, they shouldn't definitely be taken as actual diagnosis, but as a risk or whether to tell you to indicate, okay, you should go see your doctor now because you're looking good. So, and I think, Katya, I don't know if you can elaborate more on that.
Thanks. Thank you, Aubrey. So I just want to add on to what Aubrey is saying. I think that's a very important question. And believe me, there's some work. We're not allowed to share some of the results that we've got at the moment regarding increasing the awareness. But I think the first step is increasing awareness of the condition and legitimizing it, because at the moment it's either you're not diabetic or you're not or you're diabetic, and because and we understand it might be costly to the state to look at pre-diabetes as a condition and start working on it. I think the first step is increasing awareness. Getting the condition recognized. And then once that happens, people will adapt. Once people will adapt, and then people will request these tests. It's talks like these that we needed and that we need on a continuous basis, where we inform everyone, not just the scientific community, but everyone at large, that there is pre-diabetes out there. Don't rest because you haven't been tested as diabetic as yet, and then think you're okay, because you might slowly be progressing towards that. So it's stuff like that. It's increasing awareness, and then once the awareness is there, we'll get the attention of everyone, and then we'll try and find better ways or more inclusive ways that will include all sectors of society, all sectors of society to get screened, so that everybody knows their risk level of developing these conditions.
I fully agree, Dr. Kati. Thank you so much. We have to wrap up. The team behind the scenes is telling us we need to wrap up. Thank you so much to everyone for joining us for our session. Dr. Kati is breathing. You guys did very well. Thank you so much for joining us, to our guests that came through. Prevention is better than cure. And really the aim was to really bring about awareness about pre-diabetes as well. Please remember that less than 2 minutes check test that Mr. Aubrey spoke about at the end of the presentation. Please, let's make that available so that people can check themselves out. Make it available on Twitter, and then they can go see their doctors and get a proper diagnosis. To everybody, thank you for being with us this afternoon. We really loved having you as University of KwaZulu-Natal, inspiring greatness as the School of Laboratory Medicine and Medical Sciences and the College of Health Sciences. Thank you so much. Take care, everyone. Stay safe.